This lesson is on common factors involving polynomials. So finding common factors in a polynomial is the first step that we take towards factoring polynomials. Looking at a couple examples here, we're looking for common factors that are common to every term in the polynomial. So in this first example, 7x plus 14, you'll notice that there's two terms here, and 7 is common to both of those terms. So we can take this, we're going to divide each by 7. So we're factoring out the 7. And then what are we left with when we divide 7 out of both of these terms? Well, we're left here with just x, and here we're left with 2. Now you can call this reverse distribution, and we can distribute back to double check our answer. So 7x plus 14. Let's look at another example that's a little bit more difficult. In this next example, let me some more space here. In this example here, we have 12x squared minus 8x. Now in this example, we have, looking at the coefficients, you can see that 4 is common to both of those coefficients. It's the greatest common factor for the coefficients. But also x is common to both of those terms. So 4x is the greatest common factor for both of these terms. So when we factor out 4x, what we're doing here is we're saying, okay, well this binomial here is equal to 4x times something. Well, if we factor or divide out 4x from this first term, we're left with 3x, and from this second term, we're left with minus 2. So we can say 4x times 3x minus 2 is equal to 12x squared minus 8x. And again, if we distribute this, here we get 12x squared minus 8x. We get back the polynomial that we started with. Okay, let's look at an example that has 3 terms in it. So in this trinomial here, we have 5x squared minus 15x plus 20. And looking at the coefficients of each term, you can see that 5 is the greatest common factor between all 3 terms. So we want to write this with dividing 5 out, or factoring 5 out. So we're going to have 5 times something that's going to equal this. So we know if we divide this first term by 5, that leaves us with x squared. And the second term, if we divide out 5, we get minus 3x. And in our last term, we get plus 4. And again, if we distribute, we should get back the same polynomial that we started with. So 5x squared minus 15x plus 20. Okay, one more example of this. In this last example here, we have 4x squared y minus 8x cubed y squared plus 6xy. So looking at all 3 terms here, starting with the coefficient, 2 is the greatest common factor between all 3 of these coefficients. So we know that 2 goes into all 3 terms. But you'll notice that all 3 terms also have an x and a y. Now this has an x squared y on the first term, the second term has an x cubed y squared, and the third term just an xy. So the greatest common factor of all 3 of those terms would be 2xy. So let's divide 2xy out of each of these terms. So dividing 4x squared y by 2xy leaves 2x. And dividing negative 8x cubed y squared by 2xy is 4x squared y. And the very last term, dividing 6xy by 2xy, gives us plus 3. And again, we can distribute that back in to make sure that we got the correct answer. And this becomes 4x squared y minus 8x cubed y squared and plus 6xy. And that is indeed the polynomial that we started with.